Students, welcome to my second lecture on properties of aldehydes and ketones. In the last class, we have discussed about the physical properties and chemical properties of aldehydes and ketones. In physical properties, we have discussed about physical state, solubility and boiling point of aldehydes and ketones. And in chemical properties, we have discussed about nucleophilic addition reactions. Nucleophilic addition reactions. So, let me once again refresh you about the nucleophilic addition reactions. Aldehydes and ketones undergo nucleophilic addition reactions. Why they undergo nucleophilic addition reactions? Because the carbonyl group is polar. Why carbonyl group is polar? Due to electronic effect and resonance. We have already discussed about that. Electronic effect, I mean the difference in electronegativity, because of which the carbon acquires substantial positive charge. Hence, it can be attacked by the attacking reagent nucleophiles. As you know, the nucleophiles are nucleus loving reagents. Nucleophiles are nucleus loving reagents. Usually, nucleophiles are negatively charged reagents or neutral nucleophiles. There are two types of nucleophiles, negatively charged or neutral, but usually nucleophiles mean negatively charged species. So, these negatively charged nucleophiles attack the carbonyl carbon. The carbonyl carbon is attacked by the nucleophile at 107-degree angle to the carbon oxygen double bond, resulting an tetrahedral alkoxide intermediate. Tetrahedral alkoxide intermediate. What does it mean? That means in carbonyl carbon, carbon is sp2 hybridized. Now, it is converted into sp3 hybridized. So, I am saying tetrahedral alkoxide intermediate. That intermediate being basic abstract the proton either from the acid or from the water or from the solvent or from the reagent to give the addition product, nucleophilic addition product. Let me show you through some structures of what I have. So, this is the aldehyde here. This is the aldehyde. Let it be methyl group, the red ball. The blue ball is oxygen. This is carbon oxygen double bond, carbon is black, and this is hydrogen. See, this is aldehyde. Let it be aldehyde, one of the aldehyde. That is alkyl group here. This is hydrogen, and this is oxygen, this is carbon, and this is the pi bond, which is perpendicular to the plane of that carbon oxygen sigma bond. Now, this is planar because carbon is sp2 hybridized. Now, the nucleophiles will attract the carbon atom at 107-degree angle to the carbon oxygen double bond. This is nucleophile here. Now, when the nucleophile attack, it is now converted into tetrahedral alkoxide intermediate. I repeat, tetrahedral alkoxide intermediate. This is tetrahedral alkoxide intermediate. This one. You see, this is tetrahedral now. Tetrahedral alkoxide intermediate. This is nucleophile. This is the alkyl group. This is hydrogen, and this is the oxygen with the minus ion. So, oxide ion, Id means negative charge. So, this is tetrahedral alkoxide ion. Now, this tetrahedral alkoxide ion abstract the proton either from the acid or from the solvent or from the water or from the reagent to give this addition product. They say the nucleophilic addition product. This is hydrogen, this is nucleophile, this is oxygen, this is alkyl group, and this is hydrogen. As I am taking the aldehyde here, in aldehyde, as you know, there is alkyl group and hydrogen attached to carbon oxygen double bond. Okay. So, this is the tetrahedral addition product, the nucleophilic addition product. Is that clear now? Coming to the nucleophilic addition. So, in the last class, the first nucleophilic addition we have discussed is, we have discussed about the addition of hydrogen cyanide. The addition of hydrogen cyanide we have already discussed in the last class, and the addition of hydrogen cyanide. Just have a look once again, look at the TV screen where addition of hydrogen cyanide is explained. So Cn minus is the nucleophile, attacks the carbonyl carbon, resulting the alkoxide ion, which abstract the proton to give cyanohydrin. This cyanohydrin upon acid hydrolysis gives hydroxy acid. This we have already discussed in the last class. I am just referring you that how the nucleophilic addition of hydrogen cyanide takes place and what are the characteristics of addition of hydrogen cyanide to the carbonyl compound, I mean islets and ketones. Let us see that. Number 1, nucleophile is cyanide ion. Number 2, catalyzed by a base. Why base? Why base is required? Just to generate the nucleophile. Which one is nucleophile here? Cn minus ion. From where it is generated? From hydrogen cyanide. Why hydrogen cyanide does not furnish Cl minus to a larger extent? Because Cn is a very weak acid. So ionized to smaller extent. So concentration of Cn minus is very low. Hydrogen cyanide is a very weak acid, ionized to smaller extent. So the concentration of Cn minus n is very low. So rate of reaction is too slow here. That is why the reaction is carried out in presence of base. Weakly basic medium is required. Product upon acid hydrolysis gives hydroxy acid, displayed on your TV screen you see. The product would be racemic mixture if the if the carbon atom in the product is chiral. If the product has a chiral carbon, it would give racemic mixture. Why? Because carbonyl group, the carbonyl group being planar. As you know the carbonyl group, I have already shown you this carbonyl group. Once again, let me show that this carbonyl group, carbonoxygen double bond being planar. Planar I mean all the atoms lie in the same plane. It can be attacked by the nucleophile either from the front side or from the back side. Either from the front side or from the back side. Hence, if the product has a chiral carbon, it would be racemic mixture. If the product has a chiral carbon, it would be racemic mixture, which is difficult to separate. Okay. Next point, in the nucleophilic addition of hydrogen cyanide, since HCN is highly toxic, the HCN is generated by using the mixture of sodium cyanide and H2SO4. Because HCN is highly toxic, it is too dangerous to work with HCN to carry out this reaction, as hydrogen cyanide is highly toxic. Hence, the reaction is carried out by using mixture of sodium cyanide and H2SO4. The H2SO4 amount of the H2SO4 must be lesser compared to the amount of NaCN. So that Cn minus is left. It is given in the last point. The excess of NaCN maintain the alkalinity of the reaction because Cn minus undergoes hydrolysis to give OH minus, and that we have discussed already in the last class. Next reaction we have discussed, next nucleophilic addition reaction, that is addition of sodium bisulfide. Already we have discussed that. Addition of sodium bisulfide. Aldehydes and ketones, particularly which ketones? Methyl ketones. Okay. Methyl ketones only, I repeat, methyl ketones, aldehydes and methyl ketones when treated with aqueous sodium bisulfide solutions, saturated aqueous sodium bisulfide solution gives the addition product sodium bisulfide addition product, and this product being insoluble in saturated aqueous sodium bisulfide solution, it is obtained as crystalline solid. And this crystalline solid is filtered off. So this solid, when treated with dilute acid or alkali, regenerate the original carbonyl compound. So this is a nucleophilic addition of sodium bisulfide, already discussed in the last class. But let's see some important points given in the TV screen. Number 1, nucleophile is sulfide ion. Correct. Nucleophile was sulfide ion. We have already discussed that. All aldehydes and only methyl ketones give these reactions. The reaction is used for separation and purification of aldehydes and methyl ketones. We have, I've just few minutes back I have told you this, that the addition product thus obtained when treated with aqueous acid or aqueous alkali regenerate the original carbonyl compound. So this reaction is used for purification and separation of aldehydes and ketones. This reaction can also be used for distinction between methyl ketone and other ketones. If the question asked you that how to distinguish between pentan 2-on and pentan 3-on, pentan 2-on and pentan 3-on, pentan 2-on, CH3, CO, CH2, CH2, CH3, pentan 2-on, and pentan-3-on. How to distinguish between pentan-2-on and pentan-3-on? Very simple. By using sodium bisulfide, we can distinguish between these two compounds. With sodium bisulfide, it gives the addition product which is a crystalline solid. No reaction. So, by using sodium bisulfide, we can distinguish between the pentan-2-on and pentan-3-on. Any doubts, students? Okay. One more point is there. Sodium bisulfide addition product thus often is crystalline solid as it is insoluble in saturated solution of sodium bisulfide. Okay, we have already discussed all these points. These are the two additions, nucleophilic addition reaction of aldehydes and ketones which we have discussed in the last class. Now, we are going to discuss next nucleophilic addition reaction of aldehydes and ketones, that is addition of Grignard reagent. Addition of Grignard reagent. Grignard reagent, you know that Grignard reagent belongs to organometallic. It belongs to organometallic. And what are organometallic compounds? It is the class of the organic compounds in which carbon is bonded to metal atom. In Grignard reagent, the alkyl group or the carbon atom is directly addressed to magnesium. And magnesium being electropositive, it acquires fractional positive charge, and carbon being electronegative acquires fractional negative charge. So, that Grignard reagents are the polar compounds. Here carbon magnesium bond is highly polar. Let me show you that. This is the carbon magnesium bond is highly polar in Grignard reagent. Okay. So, Grignard reagent addition to aldehydes and ketones results alcohol. Another example of nucleophilic addition reactions. How come it is nucleophilic addition? How does the reaction takes place? Displayed on the TV screen. Let's have a look at that. Addition of Grignard reagent. See the mechanism. Here, magnesium with the positive charge acts as a Lewis acid. Magnesium with the positive charge acts as a Lewis acid. Hence, it forms acid-base complex with the basic oxygen of the carbonyl group. It forms acid-base complex with the basic oxygen of the carbonyl group. So, this complex formation, acid-base complex formation decreases electron density around the carbonyl carbon. It decreases positive charge density. It decreases positive charge density over the carbonyl carbon. So, making carbonyl carbon more electron deficient, more electrophilic. So, it can be easily attacked by the nucleophile. And what is nucleophile here? The alkyl group adds to Grignard reagent. Alkyl group adds to Grignard reagent. You know, just see that it is displayed on the TV screen. The alkyl group has got fractional negative charge. So, that alkyl group is nucleophilic here. So, attacks the carbonyl carbon. See the mechanism here. The carbonyl carbon, the alkyl group attacks the carbonyl carbon. The pi bond shift to the oxygen, resulting a bromo-magnesium alkoxide. Bromo-magnesium alkoxide. This bromo-magnesium alkoxide, upon hydrolysis or when it is treated with water or treated with dilute acid, generates the neutral alcohol. So, addition of Grignard reagent to aldehydes and ketones. Addition of Grignard reagents to aldehydes and ketones results alcohol. Now, how many types of alcohol we can prepare? All the three types of alcohols can be prepared by addition of Grignard reagent to carbonyl compounds. Primary alcohol, secondary alcohol and tertiary alcohol. You know primary alcohol, that is the alcohol in which OH is added to primary carbon, for example, methyl alcohol, ethyl alcohol. Secondary alcohol, OH adds to secondary carbon. What do you mean by secondary carbon? Carbon adds to two other carbons. Tertiary alcohol, OH adds to tertiary carbon. What is tertiary carbon? Carbon adds to three other carbons. So, all the three types of alcohol can be prepared by addition of Grignard reagent to carbonyl compounds. This is very important. Students, from the point of view of CHSC exam, CHSC 2021, this reaction is also very important because we can prepare all the three types of alcohols. Addition of Grignard reagent to carbonyl compound generate alcohols. Here, the first member of the aldehyde homologous series, formaldehyde. Formaldehyde gives primary alcohol. Aldehydes other than formaldehyde gives secondary alcohol. Ketones gives tertiary alcohol with Grignard reagent. The mechanism displayed on your TV screen. So, let me repeat this sentence that formaldehyde gives primary alcohol, aldehydes other than formaldehyde gives secondary alcohol, and ketone gives tertiary alcohol with Grignard reagent. Grignard reagent add across carbon-oxygen double bond to give a bromo-magnesium alkoxide as the intermediate. This being basic, asteroid proton or this bromo-magnesium alkoxide when treated with water or with dilute acid gives neutral alcohol. This is the addition of Grignard reagent. Students, addition of Grignard reagents to aldehydes and ketones results alcohols. Grignard reagent is highly reactive, so this reaction is irreversible. This reaction is irreversible. Let's see that how alcohols are produced by addition of Grignard reagents to aldehydes and ketones. I have already told you that formaldehyde gives primary alcohol, aldehydes other than formaldehyde gives secondary alcohol, ketone gives tertiary alcohol. So, we will discuss one by one that how Grignard reagent gives alcohol upon addition to aldehydes and ketones. This is formaldehyde. Formaldehyde. I am using a Grignard reagent RMgX. X is halogen, R is alkyl group. Delta plus, delta minus, magnesium electropositive, so fractional positive charge. Carbon electronegative, so fractional negative charge. Bond is highly polar. This is nucleophilic part, and this is Lewis acid. Already it has been shown in the mechanism that magnesium, as it acts as a Lewis acid, forms a acid base complex with basic oxygen of the carbonyl group. Why it is basic? Because it has electron pair. So, it forms a complex which decreases positive charge density over carbonyl carbon. So, it is more electrophilic, hence the alkyl group will attack. Alkyl group being nucleophilic, having fractional negative charge, as it acts as nucleophilic, it attacks the carbonyl carbon, and the pi bond, which is a weaker bond, shifts to the oxygen. Pi bond being a weaker bond, breaks up and shifts to the oxygen. The oxygen now becomes negatively charged. This results halo magnesium alkoxide ion intermediate. You see that? H, C, O minus, Mgx plus, and this is R. This is halo magnesium alkoxide ion. Halo, bromo, iodo, chloro, halogen. So, halo, it is halo magnesium alkoxide ion because O has negative charge. This tetrahedral intermediate, when treated with dilute acid, for example, dilute HCl, it generates the primary alcohol. This is 1 degree alcohol. So, this is the method of preparation of primary alcohol here. That formaldehyde with Grignard reagent gives primary alcohol. Next, let us take one more example. Let us start with acetaldehyde. Aldehydes other than formaldehyde gives secondary alcohol. So, acetaldehyde, let us take methyl magnesium bromide here. Methyl magnesium bromide. I am using the Grignard reagent methyl magnesium bromide. So, CH3 minus attack, the compound form is bromo magnesium isopropoxide. This is bromo magnesium isopropoxide, and this when treated with acid, this upon treatment with dilute acid, aqueous acid, gives isopropyl alcohol, a 2 degree alcohol, isopropyl alcohol. This is isopropyl alcohol, secondary alcohol. So aldehydes other than formaldehyde gives secondary alcohol. Now I am asking a question, students. You can answer these questions. Tell me, how will you prepare isopropyl alcohol by using a suitable Grignard reagent? Isopropyl alcohol by using a suitable Grignard reagent. So isopropyl alcohol is this one, or propan-2-ol. This is propan-2-ol, or common name isopropyl alcohol. What type of alcohol it is? It is secondary alcohol. Why it is secondary alcohol? Because OH is attached to secondary carbon. Why it is called secondary carbon? Because carbon attached to two other carbons. This is secondary alcohol. Okay. So that's secondary alcohol. How to prepare secondary alcohol? Don't use formaldehyde. Formaldehyde gives formaldehyde gives primary alcohol. So it is secondary alcohol. We can't use formaldehyde here. So think about that. What aldehyde we have to use? We can't use formaldehyde. And we have to prepare the isopropyl alcohol by using a suitable Grignard reagent. Let's start with simplest Grignard reagent, methyl magnesium bromide. And the alkyl group comes from the Grignard reagent. So this is methyl group. Let it comes from the methyl magnesium bromide. Now how many carbons left? 2 carbons. Tell me the aldehyde with 2 carbons. Yes, tell me the aldehyde with 2 carbons. You know that. Yes, it is acetaldehyde. This one. The reaction is given here. So reverse way, this question can also be asked. How the questions can be asked here? Question can be asked to that. What happens when acetaldehyde treated with methyl magnesium bromide and the product thus formed is hydrolyzed by dilute acid? Very simple. Answer is isopropyl alcohol. Same question I can be asked in a different way. Prepare isopropyl alcohol by using a suitable Grignard reagent. Same questions. Acetaldehyde with methyl magnesium bromide gives us. Okay. So this is addition of Grignard reagent to aldehydes and ketones. I have not yet discussed the ketones. Let me show you how addition of Grignard reagent to ketone gives tertiary alcohol. You know that ketone gives tertiary alcohol. Any ketone you use, it gives tertiary alcohol. Whenever you find tertiary alcohol and question asked you that prepare tertiary alcohol by using a Grignard reagent. So first question comes to mind is, it is ketone. Ketone with Grignard reagent gives tertiary alcohol. So if question asked you that prepare tertiary alcohol by using a suitable Grignard reagent, it is ketone. Don't consider formaldehyde and aldehyde. Let me show that on the whiteboard here once again. See here. Look at the whiteboard. I am taking acetone here. This is acetone. Remember, students, you have to well acquainted with the common names. This is acetone. This is methyl magnesium bromide. Methyl magnesium bromide with acetone. Product bromo magnesium tertiary butoxide. What I am saying? Bromo magnesium tertiary butoxide. This is alkoxide, that bromo magnesium tertiary that intermediate when treated with dilute acid. This intermediate when treated with dilute acid undergoes hydrolysis to give tertiary alcohol, tertiary butyl alcohol. This is tertiary alcohol, tertiary butyl alcohol, 3-degree alcohol. Okay. So addition of Grignard reagents to aldehydes and ketone gives alcohol. So this is the method, best method of preparation of alcohol. All the 3 types of alcohol you can prepare by using Grignard reagent to carbonyl compounds, amino aldehydes and ketones. It's a very important reaction, this one, Grignard reagent addition. And remember, it is not reversible. The reaction we have already discussed, they are reversible. This reaction is irreversible because the alkyl group with the negative charge strongly nucleophilic. So the reaction is irreversible. Okay. Next addition reaction which we are going to discuss is nucleophilic addition elimination mechanism. Nucleophilic addition elimination mechanism displayed on your TV screen. Nucleophilic addition elimination mechanism. What is this? It is the addition of nucleophile followed by elimination of water. Addition of nucleophile to carbon-oxygen double bond followed by elimination of water. So that is it is called nucleophilic addition. First nucleophile add across the carbon-oxygen double bond. Then water molecule is eliminated to result carbon-nitrogen double bond. I am talking about the addition of ammonia and its derivative is the best example under this class, nucleophilic addition elimination mechanism. Okay. So it is addition of ammonia and derivatives, that we'll discuss. You see, the nucleophilic addition elimination mechanism first we'll discuss. I have already told you that under this class I am going to discuss is the addition of ammonia and its derivatives. So, how ammonia and its derivatives, I mean the compound which are derived from the ammonia, such as hydroxylamine, such as hydrazine, such as phenylhydrazine, also the semicarbazide and 2,4-dinitrophenylhydrazine, how these molecules are the derivatives of ammonia add across carbon-oxygen double bond to give the addition product, that is N-substituted imine, in which carbon adds in double bond, that we will discuss, and we will discuss this in the next class. Okay. So, this is nucleophilic addition reaction we have discussed here. The three nucleophilic addition reaction we have discussed: the addition of HCN, addition of sodium bisulfite, addition of Grignard-Reagent. Addition of HCN gives cyanohydrin, addition of sodium bisulfite gives sodium bisulfite addition product, addition of Grignard-Reagent gives alcohol. Next reaction, nucleophilic addition elimination reaction, we will discuss. Let us stop here. Thank you very much. Thanks for a patient hearing and attending the class. In the last class, we are discussing about nucleophilic addition elimination mechanism. I have told you that it is addition of nucleophile in the first step and then elimination of water to give the product. So, that is why it is called nucleophilic addition elimination mechanism. Usually, nucleophilic addition elimination mechanism is carried out in presence of acids. In weakly acidic medium, reaction is usually carried out. First reaction we are going to discuss under this class is addition of ammonia and its derivatives. Addition of ammonia and its derivatives. The mechanism of this nucleophilic addition elimination mechanism, let us have a look of the addition elimination mechanism. You see, in the step 1, amine which acts as a nucleophile add across carbon-oxygen double bond. See, amine add across carbon-oxygen double bond. Amine adducts the carbonyl carbon and the pi bond which is weaker bond shift to the oxygen, resulting an intermediate alkoxide anion. As you know, when nucleophile attracts the carbonyl carbon, intermediate is alkoxide anion. Now you see there is H plus transfer. H plus is transferred from that NH2 plus to O minus. Why? Because O minus is more basic, so it removes or abstracts the H plus ion from the NH2 plus where hydrogen atom is acidic, resulting carbenolamine. See, it is carbenolamine. That carbenolamine undergoes protonation and thereby elimination of water molecule takes place to give N-substituted imine, resulting carbon nitrogen double bond. So, in the first step, addition of nucleophile, here I am taking nucleophile as the primary amine. In the second step, elimination of water, resulting carbon nitrogen double bond, that is N-substituted imine. This is nucleophilic addition elimination mechanism. So, here what are the characteristics of these nucleophilic addition elimination reactions? In simple way, that carbonyl group here displayed, once again displayed on the TV screen. See here, the carbonyl group reacts with NH2G, where G can be alkyl group, aryl group, hydroxyl group, NH2 group, NHPH, NHC6H3NO2 whole 2 and NHCO NH2 group could be. So, that NH2G now add across carbon-oxygen double bond to give carbonyl amine which spontaneously eliminate one molecule of water, resulting carbon hydrogen double bond, that is N-substituted imine. See the characteristics. The reaction is reversible. Reaction is carried out in weakly acidic medium. The reaction is reversible here. 1 second reaction is reversible. Reaction is carried out in weakly acidic medium. Usually the reaction is carried out at pH 4. pH 4. And how to maintain the pH 4? By using acidic buffer. You know buffer solutions. The solution having constant pH. That acidic buffer, I am giving one example here. Mixture of sodium acetate and acetic acid. By using this acidic buffer, we can maintain the pH. Now, why strong acidic medium should be avoided? Because if the pH is too low or lesser than 3, then it is now strongly acidic medium. In strongly acidic medium, nucleophile, which are ammonia and its derivatives, loses the nucleophilic character. No addition reaction, rate of reaction is too slow. That is why strongly acidic medium must be avoided. The reaction is carried out in low acidic medium. Okay, that is pH 4. pH 4 is maintained by using acidic buffer. Let us see some examples of the nucleophilic addition elimination reactions here. I have already told you that under this class we are going to discuss the addition of ammonia and its derivatives. First, addition of ammonia. Let me show all these addition reactions one by one. That is addition of ammonia and its derivatives. Derivatives also I have already told you. Derivatives are that hydroxylamine, hydrazine, phenylhydrazine, semicarbazide, 2,4-dinitrophenylhydrazine. All these derivatives, addition of derivatives, we will discuss one by one. And let me show you all these reactions on the whiteboard. Look at the whiteboard and see all the reactions here. First, addition of ammonia. This is carbonyl group. Let it be acetaldehyde here. Acetaldehyde reacts with ammonia. In simple way, we can write like this. This is carbonylamine intermediate. Now elimination of water takes place. Elimination of water. Resulting imine. Acetaldimine. Acetal. This is the addition of ammonia. Next reaction, addition of, next reaction is the addition of hydroxylamine. Next derivative we are going to use is hydroxylamine. Hydroxylamine. With hydroxylamine products are oximes. With hydroxylamine products are oxime. This is hydroxylamine. See, hydroxylamine. If you write like this, that eliminating the first intermediate, the product form. Remember, the reaction is carried out in weakly acidic medium. This is acetal dioxime. The reaction is carried out in weakly acidic medium. Why acidic medium? Why acidic medium, students? It is because the acetaldehyde should be activated for the nucleophilic attack. How it is possible? Acetaldehyde or the aldehydes and ketones, when treated with acid, it acts as a base, Lewis base. Here oxygen is basic. Why it is basic? Due to presence of the lone pair of electron on oxygen atom. So it can donate the electron pair to H plus ion or protonation takes place, resulting oxonium ion. Now this oxonium ion, as there is positive charge over oxygen atom, it strongly withdraws the electrons from the carbon atom, resulting that carbonyl carbon electron deficient, so it can be easily attacked by the nucleophile. Now nucleophilic attack is possible. That is why we are using acidic condition. Also to remove the water from the carbonyl amine. So in weak acidic medium, reaction takes place. Acetaldehyde reacts with hydroxylamine to give acetaldioxime. Similarly, acetone reacts with hydroxylamine to give acetone-oxime. Okay. So this is second addition reaction under the name under the class addition elimination reactions. Next addition reaction is addition of, let's take the same example here, acetaldehyde. Next addition reaction, addition of hydrogen. Addition of hydrogen. This is hydrogen. See, CH3 H double bond N NH2. Acetaldehyde hydrazone. Acetaldehyde with hydrogen gives acetaldehyde hydrazone. Okay, I am directly writing these reactions. Acetaldehyde with hydrogen hydrazone in acidic medium. Next reaction, addition of phenyl hydrazine. Next nucleophile we are adding here, addition of phenyl hydrazine. This is phenyl hydrazine. Phenyl hydrazine. Now when phenyl hydrazine is added to islets and ketones, it gives phenyl hydrazone. Phenyl hydrazone. This is phenyl hydrazone. Acetone, if you are using acetone, acetone also same gives the same product, that is acetone phenyl hydrazone. Here it is acetaldehyde phenyl hydrazone. This one acetaldehyde phenyl hydrazone. In place of acetaldehyde, if you use acetone, it gives acetone phenyl hydrazone. Next addition, addition of semicarbazide. Semicarbazide. This is acetaldehyde and I am using semicarbazide. This is semicarbazide. See the semicarbazide. It has got two NH2 group, but I am using this NH2 as nucleophilic for the addition reactions. Why I am using this NH2? Why not this NH2? Why it can't be nucleophilic? Because lone pair is delocalized through resonance here. So this NH2 is less nucleophilic as this lone pair is delocalized through resonance. So this NH2 is less nucleophilic. Hence, I am using this NH2 as nucleophilic, so it can attack, resulting acetaldehyde semicarbazone. Acetaldehyde semicarbazone. Okay. Next addition reaction, addition of 2,4-dinitrophenylhydrazine. Addition of 2,4-dinitrophenylhydrazine. What is 2,4-dinitrophenylhydrazine? Let's first see that. this is phenylhydrazine. If it is 1, it is 2 and it is 4. This is 2, 1, 2, 3, 4. 2, 4 dinitrophenylhydrazine with acetaldehyde it gives the phenylhydrazone acetaldehyde phenylhydrazone. This is acetaldehyde 2,4-dinitrophenylhydrazone. Acetaldehyde 2,4-dinitrophenylhydrazone. And the 2,4-dinitrophenylhydrazone are usually 2,4-dinitrophenylhydrazone are usually colored solids. Okay, usually the colors are yellow, orange or red. That is why the 2,4-dinitrophenylhydrazone is used as a test for detection of carbonyl group. I mean, in order to predict aldehydes and ketones, you can use 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine when added to aldehydes and ketones gives either orange, yellow or red precipitate. So that indicates the presence of aldehyde or ketone functional groups, I mean carbonyl group is present. So from this you can predict or you can detect the presence of carbonyl group. These are the addition reactions under the name addition elimination reactions of aldehydes and ketones. Here we are using the ammonia and its derivatives. With ammonia it gives amine, with hydroxylamine oximes, with hydrazine hydrazones, phenylhydrazones, then semicarbazones and 2,4-dinitrophenylhydrazine it gives 2,4-dinitrophenylhydrazones. The 2,4-dinitrophenylhydrogens is important because the 2,4-dinitrophenylhydrogens are the colored solids. That is why this reagent, also called Brady's reagent, 2,4-dinitrophenylhydrazine, also called Brady's reagent, Brady's reagent is used for detection of carbonyl group. Students, so we have discussed about nucleophilic addition elimination reactions. Under this class, we have discussed the addition of ammonia and its derivatives. So some important points are displayed on your TV screen. Let's have a look. Number 1, the oximes are crystalline solids with sharp melting points and are therefore useful for identification and characterization of aldehydes and ketones. Because of that reason, oximes can be used for identification and characterization of aldehydes and ketones. Second point, the 2,4-dinitrophenyl derivatives are high melting colored solids. I have already told you about that. What are the colors usually? Red, orange and yellow. Hence, formation of 2,4-dinitrophenylhydrazone is used as a positive test for detecting the presence of aldehyde or ketone group in a compound. For example, if a compound is given to that molecular formula is C3H6O, that compound molecular formula is given to. Let the molecular formula given to C3H6O, and it is given also mentioned here that this compound when treated with 2,4-dinitrophenylhydrazine gives a orange red precipitate. I repeat, compound with molecular formula C3H6O when treated with 2,4-dinitrophenylhydrazine gives a orange red precipitate. What is that compound? Either it is an aldehyde or a ketone. C3H6O, either it is an aldehyde or a ketone. So that is why 2,4-dinitrophenylhydrazine is used for detecting the presence of aldehyde or ketone group in a compound. Next point, semicarbazones also possess sharp melting points and are thus useful for characterization of aldehydes and ketones. These are also used for characterization of aldehydes and ketones. These are the some important points of ammonia and derivative addition to aldehydes and ketones. Next, let us see what are the questions we are expecting on the basis of these reactions. The expected questions are: what happens when acetaldehyde is treated with sodium hydrogen sulfide? You know this. Acetaldehyde with sodium hydrogen sulfide gives acetaldehyde sodium bisulfide addition compound, acetaldehyde sodium bisulfide, which is a white crystalline solid. Next, what happens when propanone is treated with ethyl magnesium bromide and the product form is then acid hydrolyzed? Propanone with ethyl magnesium bromide, you know this. Propanone, I mean acetone, ethyl group, whenever ketones are used and they are treated with Grignard reagent, ethyl magnesium bromide is a Grignard reagent. So, when ketones treated with Grignard reagent, it gives tertiary alcohol, you know this. Okay, students, I have already told you that ketones when treated with Grignard reagent gives tertiary alcohol. Here the question is this: what happens when propanone is treated with ethyl magnesium bromide and the product form is then acid hydrolyzed? Let us see. This is propanone, common name acetone, treated with ethyl magnesium bromide. What we are expecting here? Tertiary alcohol. First reagent ethyl magnesium bromide. You know the mechanism. I am not going to discuss the mechanism once again here. I am not going to carry out this reaction in detail. I will show that what is the product. Immediately how the product can be determined. Ethyl magnesium bromide in the first reagent is this one, then it is followed by acid hydrolyzed. So, what is the product? Tertiary alcohol, methyl both must be present, CH3 they are present. Next, Grignard reagent alkyl group must be adduced because this acts as nucleophile, it must adduct the carbonyl carbon. And next is OH. Simple. So, carbon double bond O appears as now carbon single bond OH. Carbon double bond O now appears as carbon single bond OH, and ethyl group attached to carbonyl carbon. This is the tertiary alcohol here. You know the epic name here 1, 2, 3, 4, that is 2-methyl butanol. 2-methyl butanol. This question can also be expected. Next question is: how will you prepare isopropyl alcohol by using a suitable Grignard reagent? Isopropyl alcohol, I have discussed this one, you know this, students. Isopropyl alcohol, you mean propan-2-ol. Okay, the propan-2-ol is secondary alcohol. So, secondary alcohol, how to prepare secondary alcohol? By using aldehydes. Which aldehyde? Except formaldehyde. So, which aldehyde we have to use? That isopropyl alcohol by using a suitable Grignard reagent. So, aldehydes other than formaldehyde we have to use. Okay. Let me show you once again here. This is the isopropyl alcohol. This is isopropyl alcohol, and this is the aldehyde. This must be the aldehyde containing 2 carbon atom, because Grignard reagent must have an alkyl group, and the minimum alkyl group at the lowest alkyl group must be methyl. So, methyl comes from the Grignard reagent. So, Grignard reagent we can use here CH3 MgBr, methyl magnesium bromide with acetaldehyde. The 2 carbon aldehyde with 2 carbon is acetaldehyde with methyl magnesium bromide gives isopropyl alcohol. This question can also be expected in CHS exam. Next, again some expected question, again it is displayed on a TV screen. Let us have a look. Name the product when acetaldehyde reacts with phenyl hydrogen. You know that. Acetaldehyde with phenyl hydrogen, acetaldehyde phenyl hydrogen. We have already discussed this. Second question, write the structure of 2,4-dinitrophenyl hydrogen and why this reagent used to detect the carbonyl group. You know this. I have already told you just few minutes back that 2,4-dinitrophenyl hydrogen, what is the structure? and why it is used? It is used to detect the presence of aldehyde and ketonic group in compounds. You know this. Third question, semi-carbohydrate has 2 amino groups. I have shown that. Semi-carbohydrate, I have discussed this one also. Semi-carbohydrate has 2 amino groups, but during the addition to carbonyl group, only 1 carbonyl group is involved. Explain why. I have told you that NH2, which is attached to CO, that is less nucleophilic because lone pair phylacton on adenoatomes delocalized through resonance. Hence, the NH2 which is attached to NH in semi-carbohydrate formula, you know that NH2, NH, CO, NH2. You have to practice. Remember, in organic chemistry, more pen work is required. Okay, just read it, recall it, write it. Read it, recall it, write it. Read, then recall, then write, then only you have the confidence to face the exam. So, in organic chemistry, pen work is badly required. And remember one more thing here, unless you apply the concept of learning, no meaning of learning. Unless you apply the concept of learning, no meaning of learning. So, that is why I am asking some questions here. The third question, semi-carbohydrate has 2 amino group. Which amino group is used here? Which amino group is involved in the reaction? That is the NH2 which is attached to NH. Next questions we can expect. Acetone on reaction with hydroxylamine gives 1 compound, whereas acetaldehyde gives 2 compounds that can be separated. See, acetone on reaction with hydroxylamine, 2 compound. What is the compound? Let me show that here. This compound directly, this one. You see, this is the compound with hydroxylamine, acetone oxime. Acetone oxime. Okay. See, that question is acetone on reaction with hydroxylamine gives only 1 compound, whereas acetaldehyde gives 2 compounds. This is acetone, this is only 1 compound. Acetaldehyde, this is acetaldehyde oxime, gives 2 compounds. Why? Because this exhibit geometrical isomerism. It has seen acetaldeoxime, anti-acetaldeoxime. They can be separated because they have difference in boiling point. They have difference in physical properties. Okay, that is why they can be separated. Do you follow me? So, acetone gives 1 compound, acetaldehyde gives 2 compounds because this compound, this is the oxime from acetaldehyde. It exhibits geometrical isomerism. Okay, so students, today we have discussed about the nucleophilic addition reactions, and under the nucleophilic addition reaction, we have discussed the addition of hydrogen cyanide, addition of sodium bisulfide, addition of Grignard reagent, addition of ammonia and derivative, which comes under the class nucleophilic addition elimination reactions. All these reactions are very important from the point of view of CHSE exams. Okay, there are so many reactions, other reactions are also there, but all other reactions we will discuss in the next class. Okay, students, thank you very much. Thanks for attending my class, and thanks for giving me patient hearing. Thank you.